Okay, solving the right triangle. What do we do first? 106.3, 19.9. What do we do first? Add them up and subtract from 180. So 106.3 plus 19.9 is 126.2, which leaves us with 53.8. Okay, and then the length of side A is just law of sines. The sine of 19.9 over A equals the sine of, because we know C is 55.9, the sine of 106.3 over 55.9. And you just do the law of sines. To find B, it's the sine of B we just figured out is 53.8 over B equals the sine of 106.3 over 55.9. Why did I use sine of 106.3 over 55.9 versus the sine of 19.9 over my answer from part A? Because this is a rounded answer and we don't want to use rounded answers. You want to use what's given to you, as Cam said. Use what's given to you. Don't use an answer unless you absolutely have to, which sometimes you do. Okay, number of triangles triangle problem. Okay. So, first thing you do, draw an acute triangle. Okay, you know B, B, and A, beta, B, and A. So what the angle that you know, put down here, 33.6. The side opposite of that is 32.8. And over here is 39.6. So you go the sine of 33.6 over 32.8 equals the sine of alpha over A, 39.6. Okay, so cross multiply and solve. So it is 39.6 times the sine of 33.6 divided by 32.8, and then inverse sine of the answer. And I get 1 point, that is, what did I do wrong? Oh, you know what? Mode. I'm in radian mode. Doesn't work. There. So, yeah. What did you get for an answer? 41.9. Okay. Then you take 180 minus 41.9 minus these two to get angle gamma up top. So this is 75.5. So it's 104.5 for that one. And then to figure out C, it's a sine of 104.5 over C equals the sine of 33.6 over 32.8. Okay? Then you draw your obtuse triangle. You know that beta is 33.6, B is 32.8, this is 39.6. And you take 180 minus 41.9, which is 138.1. And you take 180 minus 138.1 minus 33.6. And you get, what? 8.3. I knew it was a pretty small number, 8.3. And then it's just simply sine of 8.3 over the opposite side, C, equals the sine of 138.1 over its opposite side, 39.6. No, we shouldn't use that. Come on, Mr. Bierschbach. Sine of 33.6 over 32.8 there, because those are given to us. Okay? And then, so always on the top line, you do your acute triangle. This is your obtuse triangle. Okay? Been the same for the whole time. Okay? This one, just to show you that we're at 160.4 right off the bat. So 160.4 is here. 9.7 is next to it, and 7.3 is here. Instantly, I can look at this problem and say, no way, Jose. Why? Because your longest side isn't opposite your biggest angle. And when you see that right off the bat, boom, it's C. No possible solutions. Okay? C, no possible solutions. All right. Now, lunar crater problem. You've seen this on the quiz. You've seen this in your homework. You're going to see this on the test. All right. So you have a lunar crater. This is 111 because this is BA. There's BA. And this out here is C. 111. ACB is 42. This is 52 meters away. How long is the lunar crater? Well, what you have to do is take 111 plus 42, which is 153, which is 27 here. So the sine of 27 over 52, its opposite side, equals the sine of 42 over its opposite side, x. Then you cross multiply, solve, and get your answer. Okay? All right, when we have a side triangle, 22.9, 8.9, 15.7, side. You want to find angle alpha first. So you know that a squared equals b squared plus c squared minus 2bc cosine of alpha. If you turn that around, alpha equals the inverse cosine of this, a squared, because you move the inverse cosine to the other side, and then to move the other stuff to the other side, you're going to subtract b squared and subtract c squared. And then what are you going to do with the negative 2bc? Well, you're going to divide it. So it's divided by, parentheses, negative 2bc. And then you need an extra set of parentheses in there to make it all work on your calculator. Okay? So once you do that, and I'm going to throw these all in the calculator. Okay? So let's just clear. All right. So I'm going to do the inverse cosine of 22.9 squared minus 15.7 squared minus 8.9 squared, parenthesis divided by parenthesis negative 2, and then b is 15.7, c is 8.9. So, I didn't put two parentheses. I got to put two parentheses at the start for it to work. Now, doing it on a graphing calculator is really nice. Because once you get the first one, 135.3, you can just move the numbers around. So instead of going 22.9, if I go press Shift Enter, I'm going to find B now. So then wherever there's a 15.7, I'll go 22.9. And wherever there's a 22.9, I'll go with 15.7. That's 28.8. And then if you add these two together and subtract them from 180, so this is 1 and 14 and 6, 164.1. If they add them together, subtract them from 180, you get 15.9. Okay? So that's side, side, side. And then you hit side, angle, side with 9, 8, and 98.1. So then you put it into it the normal way, but we're going to solve for b. So it's going to be b squared equals a squared plus c squared minus 2ac cosine of beta. But you put that straight into your calculator. So a squared is 9 squared, or 81, plus 64 minus 2 times 9 times 8 cosine of 98.1. You get an answer that's too big to make sense, and then you realize, oh, that's what b squared is. So then you take the square root of your answer, and you get 12.9. Oh, you want 4 decimal places. 12.868565. Okay, now to find this one, okay, now it's the law of sines. The sine of 98.1 over 12.8565 equals the sine of gamma over 8. Do the math. And you get 38.0 to 1 decimal place. Do the same thing to find alpha. The sine, well, I guess alpha you know, because if this is 38 and this is 98.1, it would be 136.1. If you subtract from 180, you get 9, 343.9. Okay. Heron's formula to find the area. So S equals 4.2 plus 8.5 plus 11.3 all over 2. And then the area is the square root of S times S minus 4.2 times S minus 8.5 times S minus 11.3. Okay, and so you just put the numbers in, solve for Heron's formula. Area of the triangle, if you're given alpha, beta, and C, okay, you have angle, side, angle. So it's the law of sines to figure out another angle, so we could, because we need side, angle, side. So, well, just subtract from 180. So 105.2 gives us 74.8. So do law of sines to figure out like side B. So the sine of 74.8 over 10.4 equals the sine of 61.8 over B. So 10.4 times the sine of 61.8 divided by the sine of 74.8 is 9.5. And then for side, angle, side, the area is 1/2. 9.5 times 10.4 times the sine of 44.4. So it's 35.6. Was it 35.6? 34.6 for the area. Vectors, the best way to do it is to look at their component form. A is 0, 2. B is 3, 0. When we add them up, it should be 3, 2. When we subtract them, it should be negative 3, 2. So A plus B is at 3, 2. A minus B is negative 3, 2. So here A is 4, 5. And B is 2, 2, 6. So A plus B is 6, 11. And A minus B is 2, negative 1. So 6, 11 is probably this one. And then 2, negative 1 is this one. Which one is a 120-degree angle? It's either F or C, right? Okay, has a magnitude of 5. Well, this one is 3 squared plus 3 squared, which doesn't quite get you there. This one is more the 120 degrees, magnitude of 5. Magnitude and direction of each vector. If we're at -1, -3, we're right down here. What quadrant? Third. So the magnitude is the square root of -1 squared plus -3 squared, which is 1 plus 9, or the square root of 10. Then we go the inverse tangent of y over x, 3 over 1. So you go the inverse tangent of 3, and you get 71.6. Okay. See, we had both negatives here. So a negative over negative is a positive, but what you want to do is do the absolute value of this anyway, and then you get a reference angle. And since you're in quadrant 3, you're 76.1 degrees down from the x-axis. Okay, so take 180, the x-axis, plus 71.6. So it's 251.6. And the last one, the donkey problem. If this is 30, that makes this 150. You draw your line then, and you want to find x, you move your 80 over to the other side. So now it's the law of cosines. So x squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of 150, and then take the square root of that answer. Because if you don't take the square root of that answer, it's way too big. Whoops. And then take the square root of that answer. And you got 135.2. Which makes sense because if this is 60 and this is 80, they add up to about 140. So if they're in a straight line, they'd be at 140. So since they're off at an angle, they lose a little bit of their force. So they're at 135.3. Okay, questions? That's everything you'll see on the test. Okay? So obviously, if you did good on the quiz, it's just learning the vector stuff and the donkey problem. If you didn't do good on the quiz, then you have a little bit more to do than the vector stuff and the donkey problem.